Hello, welcome to Lecture 8 Surface Areas, Volume and Construction. This is based on Chapter 13 and 11 of Mathematics for Class 10 and is based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. Here I would like to request students to go through my Class 9 Maths on Areas and Volume, Part 1 of 2, which is lecture 7, and also areas and volume part 2 of 2, which is lecture 8. So kindly go through it so that understanding this lecture will be much more easier. So in my lecture 7 of class 9 maths, we had derived surface area of a cone, and for explanation kindly go to this lecture. I will not repeat here again. So surface area of a cone is defined as pi r. R is the radius of the base of the cone and L is this length, the slanted length here. So if you take a big circle, this is your L and this is your 2 pi r of this circumference, and circumference of a bigger circle is 2 pi L and area is pi L square. So here area of the sector, this AOB, we have shown that it is equal to the area of this cone, okay, and not the base. So if you want to find the area of the whole cone, so you have to add area of this, which is pi r square, times your area of this surface of the cone, which is pi rl. Okay, so the area of the whole cone, the base and this top portion will be pi rl plus pi r square, which I have not written here. So this is the area of a cone, surface area, the top surface area. We will see as we progress that how we calculate the total area of any object. So surface area of a frustum of a cone was also derived, and this is pi times s. S is this length, r is the small radius here of the top circular base, and capital R is the radius of the bottom circular base. Okay, so just go through my last lecture, you will understand this is the area of the frustum of a cone. This is called the frustum, okay, where it is the cone is cut from top. Then in lecture 8 of class 9 maths, we had also derived surface area of a sphere. So kindly go through it. Here we have taken a cone, surface area of a cone, surface area of a frustum, and we have taken some limiting case, and we have shown that the surface area of a sphere is 4 pi r. So go through it and go through my last lecture where I have explained all these steps in detail. So similarly, in my lecture 8 of class 9 maths, we had derived volume of a regular tetrahedron. So this is a volume of a regular tetrahedron. So just go through here. Of course, it's too small. You go to my lecture 8 and we have discussed this in detail. And similarly, area of a tetrahedron is, this is the area of a tetrahedron. It is square root of 3a square. A is the length of this side. Okay, so just go through my lecture 8 of class 9 maths, things will be clearer to you. This is the height, this is length, the slanted length, and this is your A, okay, the length of one of the base. Similarly, we had also derived volume of a cone, okay, so this is also given in lecture 7 of class 9 maths. So kindly go through it, how we have broken into small pieces and integrated it. Instead of course one can do calculus and find this, but we have done in a very different approach. So kindly go through it. And volume of such structures like pyramid or tetrahedron cone, we have shown that it is 1/3 the base area times the height. Okay, this is height. Just kindly go through lecture 7 of class 9 maths. I am not repeating those things here because it will consume more time. Since it is already there in YouTube, I need not repeat the same thing. And thus we learned that volume of a square base pyramid is 1/3 volume of a cube, and volume of a cone is 1/3 volume of a cylinder. So you go through this lecture 7, and volume of a sphere also we have explained this thing in detail, and where we find it to be 4/3 pi r cube. And volume of a frustum, this is the first frustum, this is the bigger base and the smaller base, this circular area. When you cut a cone, you get a frustum. So earlier we discussed about area of a frustum. Now this is the volume of a frustum. And we have, go through my again lecture 8 class 9 math, and we have come to this formula, and here this formula has been again expressed in this way. Here I have shown how to simplify this in this. Okay, just go through it. You can always pause, freeze it, and go through it step by step. These are very trivial. I am not going to tell you how to multiply and subtract and add. Okay, these are all just x into x is x squared, then x into minus y is minus xy. You just go through it. It is very simple. You take paper and pen and keep writing. And as I said earlier, the total area of any surface can be broken into many parts and then add them up. So suppose you have this cone with a base. So you first find the area of this cone, then area of the base, and add it. Similarly for cylinder, if it's a cover, this one is covered here top and bottom, and surface area. So you take area of this cylinder this one this is no cover is there, then add this to cover area, and that is the total area of the this cylinder. For even for hemisphere it is same. So this is covered here, so you find the area of the hemisphere, that is for a sphere it is 4 pi r square, so 2 pi r square will be this, and then plus here this will be pi r square. So you add this and you will get the total area of a hemisphere. So these are very trivial, this is very common sense. And even for a surface area for cube, you find the area of one side, then second there are 6 sides, and you add 6 of them. So any parallelepiped or a cube, you can add all the sides, area of all the sides. So similarly tetrahedral, if you have 4 faces and of a not a regular one, so you can calculate all the area of individual faces. And so this is easy and simple. For regular shape, use formula. Okay, so it is interesting to note here, see you have a different two structure. One is there is a dip here going, there's a depression, and here there is coming out, but the total area is same. Okay, so you have a cube here and then this one or either this one. So these are very interesting things. Suppose you have this kind of a hexagonal cylinder, okay, hexagonal faces, then you add all the area of this 6 one and this area of this hexagon, and you add all of them, you get the area of this object. Similarly for volume, if you have an irregular shape volume, suppose this is a crown and or anything, you take a water and you dip it inside this, this is your measuring cylinder, and the increase in the height will tell you how much is the volume occupied by this structure. So once you get the volume, you can weigh it and you can know the weight of this crown and volume from here. So you can know the density. Density is your weight per unit volume. Okay, this is your grams per centimeter cube. Volume is always in cube, either centimeter cube or inch cube or cubic meter, meter cube. And here you see that the density of different metals, here aluminum, titanium. As you go to gold, this is very high density, and platinum has the highest density. So this will have same volume, will have more mass here. Okay, platinum, but here it will be very light. So aluminums are generally light. It take the same volume of aluminum and same volume of gold. Gold will be very heavy. Okay. And since this lecture also deals with construction, I would request again to go to lecture 9 of class 9 maths, and basic of the construction, please go through it. And here I have shown that how to make a perpendicular line. Okay, you take a compass, draw an arc here, same diameter you take, and from here, so similarly here, and you draw these 2 points, you get a perpendicular. Similarly you can also bisect an angle. So to bisect an angle, you draw an arc here, and from this point you again draw, and so this will bisect. Like here you have bisect from point A to B, from this A to B you bisect it, and this line will be the bisecting an angle. Okay, so similarly you can draw perpendicular from any point P. So it is very easy that you take a compass, draw an arc, and from this point and this point you draw another arc. So you get this point and you have this original point. So you join it, you will get a perpendicular. So similarly, once you know how to draw one perpendicular, you can draw square. So similarly, you can draw an equilateral triangle. From here you draw an arc, and here you draw an arc of this length, you get a same side. Okay, or if you want to draw some isosceles triangle, then you know what is the length, you draw an arc from this point A and B, and you get an isosceles also. This is for an irregular triangle. So depending on what your lengths are, you measure using a scale and a compass and draw arc, and you can accordingly get a triangle. So all this this all has been discussed in this lecture, so I will not go into detail how you can draw in a circle, a square, or a pentagon, or a hexagon. All this has been discussed, so this will take me more time, because since I have already covered, I need not repeat it. And here also this, how to bisect an angle and how to draw such kind of stuffs are also been discussed in this class 9 lecture. Please go through it. So these are all just cut and paste from my earlier lecture. So construction of a same angle with a compass. Suppose you have this angle is given to you. What you do is you draw one arc and you measure this length, and then you similarly, if you want to draw similar angle here, you draw one line, and from this point you draw similar arc, and you measure this distance with compass, okay, and draw one arc. So you get this point. So now you join this point and this point, you get this angle. Okay, so it is easy to draw similar same angle. And division of a line segment, suppose you have this line here and you want to divide this A, B in the ratio of 3:2. So how you go about doing it? You draw one line, straight line here, and take a compass, and any distance, you take any distance, is immaterial of any distance, you draw an arc, but this distance has to be same as A1, A2. These are all equidistant. And from here, suppose you want 3:2, that means total is 5, so you draw 5. So you have 5 here. From here you join this point B, and then you draw a parallel line. Okay, you want 3 here, 3 unit, 1, 2, 3, and you draw one parallel line to this, and it will intersect at C. So this ratio AC by CB will be 3/2. Okay, so here I have said that is by using basic proportionality theorem. That is, what does basic proportionality theorem says? That if you draw a line parallel to any side, then the other two sides will have the same ratio. So here I have written A by A3 by A3 by A5 is equal to AC by CB. This is the basic proportionality theorem. Or A by A3 is divided by AC, you can bring it here, and this. So this is always there, but we know that we want this as 3/2. And since we want A3 and A3, A5 as 3/2, then I know since A3 is AC, so AC is also 3 and CB is 2. So this is how from the basic proportionality theorem. So how do you construct a parallel line with compass? You have a line here and you want to draw, say from this point, you want to draw a parallel to this one, a line. So you take any angle, you join this one and draw an arc from here and measure this distance. So again from same point, you draw same arc here, and since this distance is known, you draw one arc here. So you get this point and you join. Now since these two internal angle, alternate interior angle are same, so these two lines are parallel, which we had studied in class 9 in the very beginning. So kindly go through all my class 9 lectures. That will help you in understanding this more easily and more quickly. So this is again another way of drawing parallel line. You have to draw a parallel line along this one which passes through A. So you draw an arc. Again you can, I have shown earlier how to draw perpendicular here, and also in class 9 lecture you draw this perpendicular line, and then again you draw one arc here, and from here you draw these two arc, from here you draw this arc same length, so you get another perpendicular. So once you have this is perpendicular to this and this line is perpendicular to this, so this will be parallel to this. Okay, so there were theorems and all, you please go through my class 9 lecture. And here is another way, just go through it, pause and go through it. I will not tell, it's very simple. Again you draw one perpendicular line and again one perpendicular line, and then whatever distance you want, you can draw an arc and then join this point and this point, you get another parallel line. Now to construct a triangle similar to a given triangle as per given scale factor. Okay, so similar triangle is not a congruent triangle, it's a similar triangle, some scale factor will be given. They may ask you to draw 1.5 times of the given triangle, or draw half, each side has to be half, but it has to be similar. That means your angle or your corresponding side, all the ratios has to be same. So how do we do this? Suppose you have been given this triangle, okay, arbitrary, this A, B, C, and you have been asked to draw another triangle which is 3/4 its size, okay, that is B, C prime, okay, is 3/4, and all are 3/4, okay, A prime, C prime is also 3/4 of AC, okay, AC, A prime, C prime is 3/4 of AC, this is AC, and also A prime B is also 3/4 of AB. So here I have written here that BC prime is 3/4 of BC. Just go through it. This is a smaller one. So how do you do it? You again draw a line here and divide, take any measure first and then keep it constant. So you draw an arc here, here. So 4, and this is your 3. So this triangle which you will draw a new one, this in the prime, this will be 3/4 of this one. So here each side will be 3/4 of the size of the original one. So similarly here also this is slightly a bigger one. To draw a bigger one, suppose you have been given A, B, C, and they tell you to draw a triangle which is in this ratio bigger, 5/3 times the original one, all of them. So, this is B, C prime is 5/3 times. Okay, this is a bigger one. So this prime will be outside this triangle. Here it was inside, here it will be outside. So again you draw this equal, draw one line with any angle, and then draw this arc of any length, but it should be equidistant, all of them. Then now you join this B B3 to C, and then you draw a parallel line B5 to C prime, and similarly you draw a parallel line A prime C prime parallel to AC. So this A prime B will be 5 by 3 times AB, and similarly BC prime will be 5 by 3 times BC. So each side will be bigger by this ratio. So this is very easy. There will be exercises. We will see how to do it. You have to remember how to do this using this idea. So this is exercise 11.1. Draw a line segment of length 7.6 centimeter and divide it in the ratio 5:8. So this line segment is given 7.6 centimeter, and you have to divide in the ratio 5, and this is 8. So total will be 5 and 8. 13. Okay, so you draw 13, and then from this 13th point you join this point B. So, and then draw a parallel to this BC to D. So now you will have this point here, which will be cutting, this AB will cut in the ratio of 5:8. And now you get two similar triangle, that is ADE and ABC. And angle will also be same. This is common angle. This angle will be equal to this angle, and this angle and this angle will be same. So from angle and corresponding part of similar triangle, I can write, go through my earlier 9th standard lecture. This is AE by AC is equal to AD by AB, because this is a small triangle, big triangle. This is the side of the small triangle AE, and AC is the side of the big triangle. So the same side you have to, these ratios will be all same. So AD, this is here, AD is AB times AE by AC. So I just substitute. AB is 7.6 centimeter given here, and AE is 5, and this is AC is 13. There is no unit here. You have arbitrarily drawn this to just simply get the ratios. So now you get AD is equal to 2.9 centimeter, then 7.6 minus 2.9, you get 4. Or you use this formula and get it. So here we see that this distance dB is nothing but AB minus AD. Second, construct a triangle of side 4 centimeter, 5 centimeter and 6 centimeter. So this is 4 centimeter, 5 centimeter and 6 centimeter. This ABC. And then a triangle similar to it whose sides are 2/3. That means 2/3 means is smaller. It is less than 1. So now this is A prime, this is C prime. So 2/3 means you draw one line here, angle, and you again cut this line in 3 parts. This 1, 2, 3. This distance again I am repeating should be always same. Then you join from here to C. Then you draw a parallel line from 2 parallel to this 3C. So it will intersect at C prime. And again you draw a parallel to this AC. From C prime, it will intersect at A. And now this triangle, each side will be 2/3 of that. So here it will be BA prime will be 2/3 of BA, BC prime will be 2/3 of BC, and similarly A prime, C prime will be 2/3 of AC. So this is what I have written here from side, this similar triangle, corresponding part of similar triangle. Just go through it. So this is what I had said, that BC prime will be 2/3 of BC. Okay, this BC you get it here. A prime, C prime will be 2/3 of AC. AC you bring it here. So each side is now 2/3 of the original triangle. Third, construct a triangle with the side 5 centimeter, 6 centimeter and 7 centimeter. And then another triangle whose sides are 7 by 5. So this is ratio is greater than 1. So you have to construct a bigger triangle of corresponding sides of the first triangle. So it should be 7 by 5 times the earlier one. So it should be bigger. So here I have, taken from the previous slide and put it here. I didn't have space to draw this. You have to draw 12 of them. 7 plus 5 is 12. So, but here I have drawn similar one by 5 by 3. So this is your 5. Okay. And this is 3. So this is given triangle, and from point B3, you draw to C. And in this case, you have to draw from point 5, which I have not shown here. You just extend it. And then from point 12, you draw a parallel line. Here you draw a parallel line to this one, and you extend this line. So you will get this kind of thing. I am not drawing a bigger one here. It is the same thing. Instead of 7 by 5, I have written 5 by 3. So this is the one. So this triangle is bigger by 5 by 3 times the triangle ABC. So just go about doing it. Next, 4. Construct an isosceles triangle whose base is 8 centimeter. Suppose the base is 8 centimeter and this is an isosceles triangle and the height is 4 centimeter. So you draw a perpendicular or bisect, you know how to do it. And from here to here you measure 4 centimeter and then join it from here. These are all equidistance points. These are also equidistant. So you will get an isosceles triangle. Then using the similar rule, you draw one line here and 1.5 times times, you again do the similar procedure and draw, and then another triangle whose sides are 1.5 times the corresponding sides of the so this is also very easy, very similar to this, so kindly do it. Okay, 5. Draw a triangle ABC with side BC is equal to 6 centimeter. So this is your BC is 6 centimeter, AB is 5 centimeter, and angle ABC is 60 degree. Then construct a triangle whose sides are 3 by 4 or 3/4 of the corresponding sides of the triangle ABC. So this is smaller. So use ABC, and it is easy to draw 60 degree. You draw an equilateral triangle. In class 9, we have shown how to draw equilateral triangle. Take any length here and just, take a compass from your mark here, and this you mark, you will get. So this, if it is a equilateral triangle, each is 60, 60, 60. Sum of all internal angle of a triangle is 180. So you get 60 degree, and you extend this and up to 5 centimeter. Or if you have drawn a bigger circle, then make it a smaller one depending on how you have drawn it. So 5 centimeter, of course, you can draw, and then join this AC. And then again, similar idea, you take it, you draw a line, mark it here. So this is your 3/4. Okay, so this triangle A prime C prime is 3/4 the length of AC. Similarly, BC prime will be also 3/4 the length of BC, and BA prime will be also 3/4 the length of BA. Just go through it, take paper and pencil and compass box and try to draw it. 6. Draw a triangle ABC with side BC is 7 centimeter. Angle B is 45 degree. Angle A is 105 degree. Then construct a triangle whose sides are 4 by 3 times the corresponding side of triangle ABC. So this is also very similar to it, and these two angles are given. So angle AB is given. So this is 150. So angle C will be 30 degree. So you can first draw as this equilateral triangle 60, then you bisect it, now you get 30. So kindly do it. I'm not going to do this kind of stuffs. It is very easy to do it. You have to use little bit of thinking, and you should be smart enough to know what this angle 30 is easy for you to draw it. So you start with here. 7. Draw a right triangle. This is a right angle triangle in which the sides other than hypotenuse are of length 4 and 3 centimeters. This 4 centimeter, this 3 centimeters. So you have drawn a right angle triangle ABC. Then construct another triangle whose sides are 5 by 3 times the corresponding size of a given triangle 5 by this is greater. So again you can do same thing. So I am not repeating, just very simply I have drawn a sketch. So this is how 1, 2, 3, 4, 5. So you can always do this. It's the same thing they are repeating again and again so that you understand it. So this is a justification that from side and CPST. So this is a justification given. Construction of a tangent to a circle from point P. This is also very simple, which we have earlier also done, that is studied in earlier class when we were discussing tangents. So given any point and this is your circle and you have to draw a tangent. So how do you draw a tangent? You take from this and you bisect it. So this becomes the middle point. So how do you bisect? Perpendicular line you draw. At point you join this line from here to here. This point and this point you join it. So this will bisect. So perpendicular, you start from anywhere. You take from compass here, put it here. You take a compass here and put it here. You get this arc. Similarly here. So you can have a bisector here. And then from this you take as a origin and draw one bigger circle. And then this will intersect here and here. And then since this is your radius and you join these two lines, and now you know that this is your diagonal, and whenever any point this angle will subtend 90 degree. This point, this Q can be anywhere, and if you join this Q, P and Q, O, it will be 90 degree. So here also this is 90 degree. So this is now, since this is 90 degree and it is touching this circle, so this is tangent to this circle, this small circle. Okay, so this is how you draw. Very easy to draw a tangent. So here I have given steps. So kindly pause this and go through these steps. Okay, and try to understand what I have written. Okay, now exercise 11.2 of your textbook. Draw a circle of radius 6 centimeter. You draw one circle. From a point 10 centimeter away from its center, construct a pair of tangent to the circle and measure their length. So from this point center to this 10 centimeter. So again what you do, you bisect this, and once you bisect it from this point O to P, and you draw a big circle with this radius and it will intersect here and here. So this is the tangent. You now draw from P to wherever it is intersecting, and again same here from P to wherever it is intersecting. And now you can find here distance. This is OP is 10 centimeter and OQ is, this is your OQ, this is a radius, this is 6 centimeter. So I can use, this is a right angle triangle, I can use the Pythagoras theorem. So this is how you use the Pythagoras theorem. That is, this hypotenuse square is this square plus this square. So now I have to bring, these are very trivial. I will not repeat it. You have to change the side and take a square root. Now second, construct a tangent to a circle of radius 4 centimeter. So you have to draw a tangent to a circle of radius 4 centimeter from a point on the concentric circle, from a point, any point on a concentric circle of radius 6 centimeter, and measure its length, Okay. It can be anywhere. This red V kind of shape can be anywhere. Okay. It can be here, it can be here. So it is all equidistant, symmetric. Also verify the measurement by actual calculation. So from this point, and this is your center, again you can, using the similar idea, you can draw the tangent as you have drawn here. Okay, taking a center point, drawing a big circle intersecting. And then you know this distance is 6 centimeter and this is 4 centimeter. So again, this is your perpendicular. So you can find x from the Pythagoras theorem. So here I have done it. Just go through it. By now, you should be expert in solving the Pythagoras equation. Third, draw a circle of radius 3 centimeter. Take 2 points P and Q on one of its extended diameter each at a distance 7 centimeter from its center. So 7 centimeter from the center you take from each side, and draw tangent to the circle from this 2 point P and Q. So from this point P and other side Q. So it is same as this. So I will not repeat here. So here it is only one side. Here you have to do for the other side also. 7 centimeters, just a mirror reflection will be there. 4. Draw a pair of tangent to a circle of radius 5 centimeters which are inclined to each other at an angle of 60 degrees. So you draw a straight line and you draw a circle of 5 centimeters. From center you draw a perpendicular line, and you know that the opposite angle, so this angle has to be 120. So with the help of protractor you draw this 120 degree, and here I have shown this is a point, and from this point you draw a perpendicular, this perpendicular line. So how do you draw this perpendicular line? I have shown earlier how to draw. This is a perpendicular line and this angle is 60 degrees. So you please do this. 5. Draw a line segment AB of length 8 centimeter. Taking A as the center, draw a circle radius 4 centimeter. This is 4 centimeter circle I have drawn. And taking B as center, draw another circle of radius 3 centimeter. Construct tangent to each circle from the center of the other circle. So from this center you draw a tangent, and from this center you draw a tangent. So this is very easy. Again, suppose this is the point and this is the circle. Again you bisect it. This will be around 4 centimeter, and then once you bisect it you draw a bigger circle and you will get a intercept. So similarly, using this above technique you can do for this, both the circle, from this point for this circle and from this point for this circle you can draw like. So kindly do it. Okay, now 6. Let ABC be a right triangle in which AB is 6 centimeter. This is AB is 6 centimeter. BC is 8 centimeter and angle B is 90 degree. That's why it is the right angle triangle. BD is perpendicular from B on AC. This is BD is perpendicular from B on this AC. The circle through BCD is drawn. So from this BCD, this circle is drawn. Construct a tangent from A to this circle. From this point, you have to draw a tangent to this. So this circle you have drawn it. So it is very easy again. Now from this center, you bisect it. Here I have shown this green line. So you bisect it. Then you draw this dotted big circle, and this circle will intersect here. So from this A, you intersect at F. So this is a tangent. So steps are given here. So sometime you have to write steps in your answer. So these are the steps. So kindly go through it. I am not repeating what I have written here. 7. Draw a circle with the help of a bangle. Take a point outside the circle. Construct a pair of tangent from this point to the circle. So here it is again very simple. You first have to bangle. You don't know where the center is. You first draw the center. Draw a chord. Any chord you draw, take a bisector and it will intersect at the center. So once you have the center point, and then from any point P, you repeat what we have done earlier. So this thing, so you can get a tangent from any point P to this circle drawn using bangle. Because in bangle, you are not drawing this circle using a compass, so you do not know where the center is. This is how you can find the center. So steps are given here. So now since you have got the idea of how to do the construction, so kindly take pencil and compass for fun's sake and try to do this kind of thing and see whether such thing you can draw. Okay, it is easy to know that, okay, it is possible, but it's better to check it. Okay. Okay, so thank you and see you in next lecture. And I think with these 8 lectures, we have finished most of the part of the geometry. Not most, almost all, everything. Now we have to finish the other few chapters. And with that, we can go towards completion of class 10 maths also. Thank you.